they have discovered a planet in the habitable zone.
Yeah. The liquid water, basically the zone of temperature where liquid water could exist on the surface of the planet.
Yes, around Proxima Centauri, which is the nearest star.
Yeah.
Now, we've talked about that star before in relation to, I think we talked about it when there was, when we were talking about how we might travel between stars and things. There was that episode a long time ago. And then there was also the Breakthrough Starshot episode where is kind of a mission concept in which they might do that.
Yeah.
And we said at the time that there wasn't that much interesting necessarily about Proxima Centauri, or at least we just said there wasn't known to be anything particularly interesting about it. That's maybe not true now, which is good.
Yeah.
Because
so I think we were saying at the time, and obviously people who have been following the Breakthrough Starshot as well, like, if we can get to a planet within sort of a few decades, which is what this Breakthrough Starshot thing is trying to do.
Yeah.
Sorry, I say a planet, I meant a star, a nearby star. Then we should pick one that's the most interesting. And suddenly, Proxima Centauri now seems to be pretty damn interesting.
Pretty interesting. But I again, it's one of those things that you see a lot of stuff, lots of headlines, and some of them cover it fine, but the immediate reaction is that, oh my god, there's a planet that could support life.
We found another Earth.
We found another Earth
right next door,
and it's probably not true.
No, it's
in that way. It's not going to look like Earth. At least the chances are it's going to look quite different.
Yeah, for sure.
I would say.
For a start, it's really close. Well, it seems to be really, really close to the star.
Yeah, 11-day orbit.
11-day orbit.
Which is mad fast.
Which is, so it's basically just pissing around, like, really close to the star.
Yeah.
The star itself is just completely different to the sun.
Yeah,
it's a totally different type of star. Yeah. It's a red dwarf.
Yeah.
Which is it part of so Alpha Centauri is a binary system, right?
Yes.
With
and
two
then Proxima's
stars
nearby, but it may or may they think it might be gravitationally bound to those to the Alpha Centauri.
Yeah. So is it system? We don't know if Alpha Centauri is slightly closer than Proxima Centauri, or is Proxima Centauri literally the closest?
I think it's the closest.
It's crazy, isn't it? That we just look at the closest star, literally our closest star, and there's a planet there.
Yes.
And actually, you read the paper, they say that they can't rule out the existence of another much larger planet also in the system.
Yes, yeah.
So there might be several planets there.
I think they detected this with the radial velocity method, which is where you kind of look at the pull and... So imagine when a planet's orbiting a star.
Yeah.
It sort of tugs it away from the Earth when it's behind it, gravitationally, if you like. And when it's closer, it tugs it towards. And so you end up with a Doppler shift in the light. Shifts to the red if it's being pulled away, shifts to the blue if it's being pulled towards
just in the star itself.
Just in the star itself, and that's how they worked out it was there.
And it's the shifts are tiny.
Nothing.
Absolutely tiny.
It's a small star anyway, with a small. The planet's about the size of. They think it's at least 1.3 times bigger than the Earth, at least, but that's the minimum mass.
Yeah, that's one of the constraints I think of that radial velocity method is you can only get a minimum mass.
Yes.
So about 1.3 times the size, or bigger, I guess.
Sure.
They must have some kind of upper bounds on it, but I mean, I don't know. I actually don't know, so I don't want to even speculate about that.
Sure.
But yeah, it's really cool, and
it's locked. So it's because it's close in, though. It's locked to the star, isn't it?
It's thought to be, I think.
Again,
we don't know, but probably it's either going to be tidally locked, so one side of it faces the star at all times, or it's going to be in like a spin resonance where for every orbit it has like 2 or 3 rotations or something like that.
Okay.
Probably just because it's so close.
Sure. I mean, if it's tidally locked, there is some debate in science circles about whether a tidally locked planet close to a star could be habitable. There's some people that think it couldn't, and you need that rotation. Some people think, if you've got a big enough magnetic field, strong enough magnetic field, you can retain the atmosphere and
distribute heat around.
And distribute heat back around.
Yeah.
And so there's others that say there maybe is a kind of on these types of worlds, if it is tidally locked in that way, there's a habitable ring around the planet between the side that is being scorched by the star and the other side, which is sort of cold and desolate, presumably.
Yeah. Which is nuts. I mean, I'm not sure how seriously I take that, but just think about it for a minute and what it would be like being on a planet like that. Say that that's just where, a civilization or something or life has started in this band, and you just exist during this entire time in this kind of like perpetual sunset, where on one horizon you've got the sun, like illuminating the sky, and on the other horizon it's dark.
Yeah.
And if you venture too far either direction, then you're in like either like some kind of horrendous radiation-soaked desert, or like the horrible like winter sort of.
Yes, yeah. And you could have the atmosphere kind of condensing out, or freezing out on one side.
Yeah, like carbon dioxide,
being
snow,
stripped
and shit.
And it could be a crazy, crazy place. So the other thing is, not only is that tidal locking potentially a barrier to it being habitable, or having life on it or whatever.
Yeah.
It's also next to a star, which is a red dwarf star, which is called a flux star.
A flare star.
Flare star.
A flare star.
A flare star. Now, a flare star happens to enjoy throwing out huge amounts of X-rays and other stuff.
In like unpredictable bursts.
In unpredictable bursts at luminosities that are way brighter than the star. They take this star from being something like, was it 0.14 or something like that, the brightness of the sun, up to the brightness of the sun during one of these flares. That's not good.
No, it's like a 10 times increase in brightness.
Yes.
And that's like a full spectrum, like X-rays and everything just being chucked out of the star.
That's like 400 times the dose of X-rays you get on Earth, I think, and that's with Earth's magnetic field and everything. Yeah.
So that planet is going to be taking those X-rays hard.
So that's not ideal for life.
Definitely
really.
isn't. No.
I mean, it's not.
It's not just X-ray. Presumably, with that comes UV and everything. It's just a horrendous amount of short wavelength damaging shit.
Yes.
So
I mean, maybe it will just be a kind of barren rock that happens to be in the zone where there is liquid water, and it won't really have an atmosphere. We have no idea about any of this.
Yeah.
And something like James Webb might help us answer that question.
Yes.
Maybe.
So this is exactly the kind of thing that we need for upcoming missions. Like, so James Webb, which is going to be able to look. Right now we don't know if it transits, I don't think, in front of the star. So transit's obviously just like line of sight from the Earth.
Yes.
Moves in front of the star.
Oh, that's true.
And James Webb, I believe, needs transits to get the spectral data from the atmosphere.
To get it round the atmosphere.
Yeah.
Okay.
So if it does transit, then we'll be able to look at it and be like, okay, shit, there's like an atmosphere, there's oxygen. Can you imagine that? Oxygen or something nuts.
Yes.
So some crazy disequilibrium.
Yeah.
Water vapor. Hell, that would be mad. Water vapor. Yeah, that would be insane.
Yeah.
I mean, get over there as soon as possible. Yeah. So upcoming missions like that and Breakthrough Starshot, as we already mentioned. I mean, there isn't really. I can't imagine like a better target for Breakthrough Starshot. Really?
Well, yeah. I don't know how. I can't remember the exact stats of how long it takes Breakthrough Starshot is planned to get to this place, and how much different it would be if they went to, I don't know, Barnard Star or something. A star a little bit further away.
I think it's about 20 years to get to Proxima Centauri.
Yeah, within a kind of sort of time bracket, I suppose. You want to pick. So it's going to take. You don't want to take it. You don't want it to take more than, I don't know, 50 years, say. But within that gap between 0 and 50 years, you want to pick the best target you can go to. And Proxima Centauri might be the best. The best shot we have at finding a habitable planet and visiting it. But just because it's the closest, if we've only just discovered that around that very close star, who's to say there's not other better targets located around other close stars?
Yeah,
so
sure.
It could. I mean, certainly. That certainly could be. There's no reason why there shouldn't be. That at the moment is the priority target, but as the research comes through, that may change.
Yeah, sure. And this is the thing. The big efforts for exoplanet searches. Kepler, very high profile mission, has been the Kepler volume, so the region of space that it's looking at is fucking miles away.
Yeah,
it's
sure.
It's like hundreds of light years away.
Yes, yeah.
It's way out because it's trying to get this idea of statistics and it's trying to capture as many stars as possible.
Yeah.
So it's not. There's no point in looking at the close stars because you have to keep swiveling around.
Yeah,
So actually, our close neighbours haven't been examined that closely for planets, which is why they're only just being found now.
Yeah.
So yeah, you're right. I mean, we might find a whole bunch more. In 10 years' time, we might know that all of our nearby stars have planets, and just a case of picking a trade-off between, the amount of time it takes to get there versus the sort of scientific return.
Yeah, I mean, my hunch would be that you would want to try and find some star that is more comparable to the sun, with a planet orbiting it around in that version of the habitable zone, in the Goldilocks zone, as opposed to going for these red dwarf stars, which are they're the most common stars, I think, in the galaxy. But I mean, who knows? But based on the data we have, the presumption is that you're more likely to find life somewhere like an Earth-like planet, an Earth-sized planet in that kind of zone, I guess.
Yeah.
But I mean, who knows? Who knows?
Yeah.
Next to a flare star is not ideal.
It's not ideal, but there's more to learn from going there than just being habitable and potentially having life there. It's not the only reason you'd want to go there. Like we'd learn just generally about planetary formation.
Yeah, absolutely.
And, sort of the diversity of planetary systems and
True.
shit.
But I mean, let's not make any bones about it. If we're going for the highest chance of finding a planet with life on it, that's obviously what we're going for. Yeah. But
because you answer all that other shit anyway if you find something like that,
or you get more data on it anyway. Yeah. That's the most interesting thing. It's got to be.
Yeah, so, I mean, why do we want to learn about planetary formation and planetary system formation? It's because we want to understand...
A lot of it is to understand our place in the universe.
Yeah, our origins and how common.
I mean, those things are definitely interesting as in of themselves, but I mean, that's what we're doing. We're going to look for life. That's what we're really doing.
Yeah, I agree.
Yeah, so we will see. We will see.
I mean, it's just exoplanets just keep getting more and more interesting. There's just so much cool shit coming in from exoplanets.
I mean, the fact that we found something this close, that realistically... Yeah, I mean, I guess realistically could be visited in our lifetimes.
Yeah, we could. It is possible if they get their act together with Breakthrough Starshot.
Forgetting singularity stuff. That's what we always have to say.
yeah. Just always have to caveat it with that. Yeah. It is actually conceivable that we would see images of this planet from a probe in our lifetimes. Yeah. That's fucking nuts. Unbelievable.
A different star system, another sun.
Yeah. Different sun, a planet in a different star system.
I can't even imagine.
No.
I can't even imagine.
You know, when the pictures come back of like Pluto and stuff, and you're looking at it like, fucking hell, it's a whole world, and mountain ranges and stuff, and just imagine looking at that, but thinking that it's just a completely different system. Yeah, well, if formed in a totally different.
Yeah. The sun, the kind of red, orangey coloured sun.
Yeah.
In the background.
Like rising above the planet. Oh man.
I tell you what, those red dwarf stars are weird. I didn't know much about them before I started.
They are weird. It's a good point.
I can't believe how long they burn for.
Yeah.
It's that star, Proxima Centauri, might last for about 4 trillion years. Right. That's 300 times the age of the current universe.
Fucking hell. Which is, I had no idea that you could get things that old in the universe that lasted that long.
Sure. I thought, I don't know how long it takes things like black holes to evaporate and that sort of stuff, but that's a long time. I didn't realise stars lasted that long.
It's like the projected heat death of the universe is on the order of like hundreds of trillions of years, I think.
Not sure.
I think it is.
Right.
I mean, obviously, if I'm wrong, just
I'm
an idiot, correct me. But I think it's on the order of hundreds and trillions of years. So if you've got stars that are lasting for, say, 4 or 5 trillion years, they're getting up into that kind of, just a few generations of them, and then the universe fizzles out.
It's crazy when you think of you think of the age of those stars, the age they will get to, and how young the universe is. Like, we keep coming back to this.
Yeah.
We're right at the very beginning. We really are right at the very start of the universe still. The very first little slice.
Yeah. Which is weird.
It is weird.
Why are we here? Surely you'd expect us just like by like random chance to be somewhere in the middle. Right?
Oh, right, I see what you mean. As in you'd expect us to be appearing at the highest level of planet formation, which is not thought to be now.
If there's like a rate of civilization production in the universe.
Yeah.
You'd imagine that it has some kind of a bell curve, like
which fits on the planet forming curve.
Yeah,
then you'd imagine
it probably does.
Then
you'd if you're just gonna just open your eyes one day and you're a civilization in the universe, you would expect to be in the middle of that bell curve rather than where we are, which seems to be right near the beginning. What's going on there? I mean,
nothing. It just happens to be when it. Someone's got to go in that lower.
It's just mad though. It's just a mad thought.
It is crazy how young it is. It is crazy.
Yeah,
very crazy. So we will see how these projects develop. What?
I'm just laughing at that. Don't worry.
Okay. How these projects develop over the years.
Yeah.
And we will see if they pick up any better stars.
Yes.
Maybe they will. Better candidates.
One thing actually. If So if you can get a habitable planet around a red dwarf, right? Maybe this one is, maybe this one isn't. But if you can, and the star lives for trillions of years.
Yes. Oh yeah, it's going to be stable for longer.
Yeah, you'd think it would be stable for fucking ages.
Yeah.
I mean, I don't really know where I'm going with that, because you don't need trillions of years to get to what we have now. So.
But I guess the chances increase, right? If you've got a stable environment for a longer period of time, a stable, habitable environment for a longer period of time, presumably that increases your chances of developing a biosphere and developing intelligent life. I mean, we're nowhere near. That star's only something like about 5 billion years old, so it's only a tiny, tiny slice of its full lifetime. So it's not. It's had as long as the system, our solar system, to develop life and things. So.
Yeah, but it could be in like 100 billion, 500 billion years that actually then you start getting life. Who knows?
There's some change in the orbit or something. And it just shifts enough, and there's some changes in the volcanism and stuff on there that means it produces a biosphere. Crazy.